Yesterday, this vehicle had no crank, no start conditions. Essentially what would happen, the vehicle would not rotate. Long story short, the vehicle broke down on my cousin. They tried throwing some parts at it, alternator, starter, and the battery with no avail. They tried some things, didn't work. So here it is. What I found out yesterday, and I wound up getting it started, was simply the vehicle thought it was running. The car thought it was operating. The fuel injectors essentially flooded the vehicle. That was working. We had an alternator code. We also had compressor activation. Now, with the vehicle still incapable of cranking, so we had signs of a running vehicle, but it legitimately was not capable of rotating and turning over. So once we heard the injectors, had the code, compressor activation, started looking over some things, putting the context clues together, and overlooking some information. The vehicle had an RPM signal. Now, I put a note in the last video of what I screwed up, and there, hindsight is 2020. I could have definitely handled this differently. I scoped the 3X sensor when the values was present in the PID data on the 18X sensor. So my mistake. The 18X sensor is the more integral sensor, but the PCM utilized both the 18X and the 3X sensor for feedback information to operate the vehicle in optimally. So, and I got the vehicle running. I'm gonna show you that it starts up. Also, there's no codes present. So I just checked it today. Today it starts up perfectly fine. There's nothing present. Let's go current. No fault codes. I got some notes taken here, my chicken scratch, but I plan on doing some basic tests, and basic meaning that we are going to hook up the oscilloscope on the appropriate sensor, the inputs going to the 18X sensor and the output going to the PCM. So we're going to hook up the oscilloscope, do a wiggle test, see if there's any change. And mind you, I did not change the crank, the ignition control module or the crank sensor. I do have all those parts from O'Reilly's. We have AC Delco module, 3 new coils, because I know where I need to be. I just didn't see the issue. And so the findings was simply, I was able to start the vehicle up, move the wires, and it started to hit. There was a lot that the last video entails, and it just shows what I've been through. But long story short, we had flooding conditions. I didn't change the plugs or anything. I was able to move the module wires, and the car eventually was having signs of trying to crank because we had fired in. Started right on up. It's been running ever since. So the good thing was the issue presented itself 3 times, and when I moved those wires 3 times, it wanted to make a conscious effort to start. And within those 3 times, the injectors were pulsating as if the engine was running, but it wasn't. So it was off, key on, injectors just going crazy, buzzing. So just to address some of the things that were in the previous comment section, which was, most of my mass following, 2 comments. One person mentioned that, let's see here, if it was the CAN gateway. There's on this module. The ICM ignition control module, there's no CAN gateway. And I think there was probably some miscommunication as far as like if I did bring up CAN gateway out, it was just out of conjecture and speculation before I started really looking into it. I do apologize for that. But this doesn't have a CAN gateway. It only provides an input signal a square wave from the crank sensor, and then that signal goes back out to the PCM. And it should be displayed in the wiring diagram. I'm either going to have it as I'm talking, or it's going to be at the very end of the video. But this does not have a CAN gateway system in the ignition control module. Another person mentioned if it could have been like a diode in the AC compressor. And I would say no, there's no diode in AC compressor. A diode pretty much in a like an alternator. The alternator has an alternating voltage. The diode is going to be directionally biased and only allow the voltage to go one way. So it can't backfeed. It's only going to go one direction. So I was assuming that he thought maybe the alternator, being that the alternator was engaging, maybe there was some issues with, I don't know, some electrical magnetic field or some voltage generating going back into the circuit, because the alternator does feed power to the compressor, but the relay is essentially just a switch and it breaks the connection. The PCM still has to ground out the relay to activate the compressor, which will supply the power that's with the alternator. So that only lightly supplies voltage to the AC compressor once the computer grounds the relay. I want to see if I can show you some of the PID data that we had previously. The video, if you go back and look at the video, let me see if I can go to it without having to do all that. Should be, let me see if I can pull up a code. It's not going to be, it's going to be in there though. Let me go back out because I don't think I can access it while I'm inside a control module. Go to history, 2002, nope, no, yeah, well, nope. Let's see what this says here. So these are the codes that we had before. So we did have P0620. The last test it had during the ignition cycle, it failed, but it has passed and failed previously. This vehicle does need an ABS module because of because of a killed connection. Let me see here. So we have mass airflow codes also. So this is another clue that I didn't mention, the P0120. There's the mass airflow code only is going to manifest if the vehicle thought it was running, because there's no need for a mass airflow to gather any information. So if you look at the PID data in the previous video, that will show we had mass airflow information. Let me see if I had it. I took some screenshots. Go ahead. I think because I got connected to the internet, it won't take its precious time. Where's my... That's weird. That's weird. Okay. So this was some still shots of the vehicle from yesterday. So look at the 18X crank sensor. It has a value. I do have the key on engine off, so we can look at this. Look at I checked the 3X sensor yesterday, but that was the one that didn't have any RPM value. They had a desired speed up there of 1216. We had a duty cycle of the injectors. So let's run up inside of the. No, I'm not paying all that money right now. Let's go inside of here. Let's go back to our PID data and see if we can compare the information. So for the most part, I got the similar PIDs pulled up from yesterday. Now this is with everything working. The 18X does show a value of 361 RPM. We do have a value in the injector pulse width modulated injector PDM PID. Mass airflow sensor does show a value. But I do believe now, being that everything's working, this was likely just a default value because of the backfeed of the voltage. So vehicles operate off of the signal voltage. I'm gonna try to emulate a signal close to 400. I'm gonna see what happens. What happened if I become a resistor and I transmit some bias voltage on the 18X sensor, with me being the resistor, see if anything changes. It's just an experiment to see if it works. We can see our desired speed, desired idle speed is here. Now, in hindsight, now that I'm looking at things, I'm thinking that because of the temperature difference, when I was able to start the vehicle, we started having values because the desired idle speed is going to change based off the engine temperature. So everything's working. This is working PIDs with no issues. These are the values that needs to be present, because there's no check engine light codes. The vehicle starts up perfectly fine. Let me see if I can go back to the other one so you can compare it. So in my gallery here, this is what we had when everything was malfunctioning. So the command was off, but we did have an on command for the alternator. But the RPM, the 18X crank sensor was different. It was at 467. You know, so like I said, the internet. So these are different now. These are different. Now, I remember the Spark Advance having a value, but I don't think I had that one pulled up. Did I? Nope, I did not. Maybe I'll have it on live, the old video. Let me show you that it starts up perfectly fine, and I'm going to hook up the oscilloscope, do a wiggle test, and see if the values change, and try to emulate a signal and see if it responds like it did yesterday if I change the voltage value. Let's see what happens. All right, after starting the car and shutting it down, I did notice there was some differences also. And I mean, it could be, like I say, these are just probably just default readings depending on the position. So, and again, we're just finding out some information. We're just trying to get to the bottom of it. So if the crank sensor hasn't detected a position, the value is going to change because of how the Hall sensor works, and I'm pretty sure the interpretation of the values is going to be different in how the module perceives it and send it back out to the computer. So I can kind of understand why the 18X crank sensor is going to change, or 3X or whatever, but maybe one's a little more sensitive than the other. Here's another thing: the current gear 3. I'm not sure why it's displaying that, but it's not in third gear because the car is not running. Before, when it wasn't running, we did have a current gear of the value 3. So theoretically, it shouldn't start up right now because it thinks it's in gear 3. Maybe that's just the default command, I guess. Not sure, but let me see if it starts up since I just happened to notice that. The value did change to gear 1. So in an off state, I did go back to gear 3. So this is new. The 18X crank sensor is not displaying any RPM right now. Also, the desired RPM drop from 1200 to 1192. So that's different. So we're just gathering some information here. So let me, it's like every thought that I had from yesterday just doesn't seem to be applying to the day from what I'm seeing. Let's try this right here. I'm going to do a wiggle test and see if the 18X crank sensor changes and before we get hooked up on an oscilloscope. So let me zoom in here. Ignore the glare. So let me move the wires and see if anything changes. And you know, we could definitely compare this information when we change the module. This is interesting. So a lot of the concepts that I had yesterday are just kind of like falling flat on its face. Now, one thing that isn't displaying that it was displaying yesterday, if you look at the engine speed when I initially jumped into the live data, it was at 2000 RPM and then it changed. So that is one difference. All right, we're at the ignition control module. These are the wires going directly into the coil. And you can see, I know you can see my little marks that I made yesterday. Don't get on me. I'm going to make more today. So we're going to hook up to the, so we hooked up to the purple yesterday, and that's the 3X. The 3X, I want to say ICM to PCM. That's channel D. So we got A, B, C, and D, which is the purple one, which goes to 8-pin on PCM. So D on the module, and it goes to the number 8 pin out on the PCM. The light blue and black on C, A, B, C, right here is what we need to be. This goes to ignition control module from here. It takes the signal from here and then goes to the PCM. So C, light blue and black, is what we need to be. We're going to hook up there. I'm going to make some more witness marks. We made it to C, light blue and black. That's going from the ignition control module to PCM, and now we need to figure out which one goes from the crank position sensor to ignition control module. Let's see, it's either going to be G or H. A, B, C, D, E, A, B, C, D, E, F, G. G is yellow. We were hooked up on blue and white yesterday because there's my marks there, so we're gonna hook up right up on yellow right here. Uh-oh, totally missed that one. All right, let's hook up the oscilloscope, look at the values. I'll remove that glare so it'll help. So we hooked up on the input and outputs of the 18X crank sensor. And so I'm just removing one of the pins. The yellow wire, which is the terminal G on the ignition control module, that's going to the crank position sensor to the module. So that's our green green here. That's going to drop signal. And with the 0, that's our information going directly from the crank sensor directly into the module. This orange one that's going to drop, that's our information going from the module to PCM. So that's the static voltage. That's what we see with the engine on, ignition on, vehicle off. What I'm gonna do, I'm going to do a wire wiggle test. I'm just going to move these, see if the values change. Move the connector around. What I do there? Something happened. Is that me? Because I touched. Okay, so right here I touched the connector, the pin, the piercing pin going directly into the wire. That's why I did that. So make sure I gotta. So I just gotta be careful. So that green dropping, that was me. Let's see if I can play with it and get it to do it again. Nope. And I'm on a 20 millisecond per division scale. I'm moving around, nothing else is happening. I'm gonna go to the crank sensor, move around here, and make sure our information on the green is not changing. Moving the wires around, moving the ground wire that's under the module, moving that around. Nothing's changing. I'm gonna go to the PCM around here, even though the issue didn't present itself until I went to the module. Move that around. I mean, just going everywhere, just moving things around. Nothing has changed. Going back to the module, moving the wires around. I want to see that. Just moving things around here. Want to move the connector around, coil towers. Nothing has changed. All right, let's look at the signals. And what I'm going to do next, after we check the signals and do some more wire movement, see if there's any consistencies with the waveforms, and then we'll try putting bias voltage to see what happens. I can change my time base here to get a little bit more in depth. Oop. Everything's up here. Everything's falling. I want to get more fine-tuned. I would increase the time base by dropping it. 10 millisecond per division. Does sound like it got a little slight miss to it too. Let's do this. Let's see if we can pull up any misfire data. It's real faint though. Come on here. Should have had misfire right there. It just sounds like it. It doesn't necessarily have to be a misfire, but it just sounds like it. Oh shoot! I know I need to put it somewhere else. Just bear with me. I'm trying to show how smooth this engine runs. It's slipping off. Still pretty good though. It's like with the misfire. There's just a counter. No misfires were documented. Let's go back to the oscilloscope. Where's the maxiscope at? Right there. So we have a 0 to 5 volt wave. It's going up to somewhat to 6 volts. I could probably get an average. Let's see if we can reduce this to 10 volt scale. So this is so our input going in is a little higher, and our output that's going out to the PCM is at 5 volts. We can get a measurement here on the input, which is going to be channel B. Let's get a average voltage. We can get an average voltage. What's the average? Oh, never mind. Well, I don't know why it's showing average. I would imagine if it was average, it would probably be like 5 volts or something. Let me see. But it's probably picking up the top and the bottom. And it's probably getting a division between the two. Let's go. See what the maximum says. If I can get value, go to the maximum. Alright, there's those values. Let's take off average. And that's closer to what I was looking at, the 6 volts. That's what I see. And then the 5. Here we are with the values of our input on the green trace and our output on the red, the orange, or the orange. And what we see is the input is on the maximum voltage it's around 6 volts, and then the output going to the PCM is around 5. So now I change the scale to 10 milliseconds for division. Those look fine. Change that to 20. Now, I tried to wiggle test to see if there was anything different. Nothing changed as far as the values dropping off or anything. So what I'm going to do, we're going to shut it down. We're going to go to live data, and then we're going to emulate a signal and see what happens, see if anything changes. Now, we know at the off state that the values, it supplies bias voltage, so it sees the voltage value. Let me just get an idea of what the computer sees. We're going to go back into the live data here. Let's go to engine data 2, and then we can just look at the 18X crank sensor and then the RPM and see what it says. So we're going to get engine RPM desired, and then we'll look at so we can see here, because the engine's warm up, it has a lower desired RPM now. So what we probably saw yesterday was just a cold start open loop. So that's just something to note that I'm just also learning. You see our injectors here. Where's the 18X crank sensor? The gear 3 is still the command. The gear command is still at gear 3. I'm kind of losing hope here. I'm like, what the hell's going on? That's weird. All right, we're gonna go to. Let's see what I'm gonna do. Our red, the one that's going to the PCM, which is the dark blue and black. This is where our red trace is. I'm going to, being that the voltage value is high, it probably picks up the drop off. So I guess it will be considered a low side switch or whatever. I'm going to try to be the resistor and drop the signal and see if the RPM changes. So I'm going to grab this in here, and I'm going to ground myself and see if the values change. Let's look at that. I'm going to try to do it with me touching the alternator too. So our 18X is what we're going to look at. I'm just going to wonder if that increases. Oh, just hot. So I'm touching the battery negative. And nothing's changing. I'm going to touch the positive side of the battery, see if anything changes. Nothing's changing. I'm going to try one thing. I'm going to put a test light to it, because maybe I don't possess a strong enough value. I probably can produce like 300 millivolts or something. That's probably not significant enough. I'm going to take a test light. I'm just going to use the connected here to the alligator clamp, and I'm just going to use this end here to see if I can generate a signal. I'm just going to touch the alternator, which I did. See that changing? So it does detect the drop-off signal. Let me see if the RPM changes also. So what this says, the engine, we can check the codes too and see if we have a see if we got a code for the alternator. So what this means is that it picked up a ground signal to generate the 18X crank sensor. So what got negated, something else got explained. So it's fine. That's why we're testing some stuff. So what I'm gonna do, I'm gonna play around with this, and then we're gonna let's check and see if there's any codes present, because I'm curious now. So technically we should have an alternator code. Why did I do that and I was already in there? It's a habit just to back out of it. We should have some codes for the alternator and the mass airflow sensor, right? Maybe. Nope, no fault codes. It's weird, man. Well, even then, like the car didn't start for a while, so it was probably like a stronger ground, but at the same time I'm not going to sit there and ground it out because the test light is obviously working. Let me see if I can do this for like a minute or two, because I mean after a while it had to have been getting some kind of ground interpretation to where it influenced the injectors to operate. So it could have been because it needs the 3X and the 18X crank sensor to function, and it's a possibility it was just the appropriate conditions just to be able to activate the injectors only, and it determined that it was working. So let me go to engine data 2. We're gonna go back to the 18X crank sensor. We're gonna go to engine speed. I could probably try screwing around with the 3X crank sensor also, and see if I do those in tandem, if it would change anything. Did I get what I need? I got desired RPM, engine RPM. I think that's everything. I think that's all I need. Let me see what happens. I'm just gonna go here. I'm just gonna go to the closest ground. Well, so let me try one more thing. I'm gonna jump on the signal, the output going to the PCM for the 3X crank sensor, and then I'm gonna try to emulate a signal with both of those and see how the engine responds. So we're gonna go from the yellow, the G pin, to the blue, A, B, C, D, E, F, G, H. So this is what we need to be right here, because this is going to the, nope, we need to be at the, I take that back. We need to take ICM to PCM. So we're on, took the yellow, and then we need to go to D, which is the purple. Let me see if where's my light at? So we need to go to D. Which is purple right here. We have a lot of holes in here. Some people are going to be aggravated with that. Yep. All right, let's do this. So I'm gonna try to influence both of the signals and see what happens. Okay, let's see if we can zoom in. I'm just gonna go right to the nearest ground on the alternator. And I'm just gonna pretty much bridge these two. See if I can get them on here. Bridge this, do this, and maybe get this stuff down there somewhere. Just like that. Like that. And I'm gonna take my test light, do some more tapping. So, like I said, it needs both of those signals, and now so that's probably what had happened. Yep, see, I hear the injectors now. So the injectors are working now. So likely what had happened, so I'm getting a little bit further in life, the module probably grounded out. I don't think there was a grounding. It could have been, no, I don't. I'll tell you what we could do. We could also splice into the wiring harness and see if there's anything inside the wire loom. Maybe there's some mended wires together because of the heat. I don't know, but we would do that also. So now we know there has to be both signals, like the information stated. You got to have the 3x and the 18x for the vehicle to function. Let's go and see if we got any check engine light codes, because if we do, then all this logically makes sense. We should have alternator codes and mass airflow codes, possibly. Let's see what comes up, because that was enough to think the engine was running, but there's no, hopefully we're right. Nope. So I probably need to do that for a little while, because those injectors were operating for several seconds. Let me see if I can, let me just do this for 30 seconds and see what happens. I'm not going to hurt anything, because we already seen the extreme conditions of what it can do. So I'm going to emulate this signal for 30 seconds and see if it'll generate a code, because what happens, the vehicle needs to detect certain conditions for a particular time frame before it determines that there's a fault. Sometimes it's for like 2 seconds, sometimes for 1, depending on the parameter that it's monitoring. Because after a while of thinking it's running and not detecting certain conditions, I mean, it's going to detect a problem. Yeah, we should have a check engine light, because I heard heard some stuff go on inside the vehicle. All right, let's see what we got now. This will answer quite a few questions. Let's see what we got. No, are you serious? There's no codes. All right. Well, I have got some stuff answered, so I'm not gonna break my neck over it. I could give it another try. Probably flooded his car out. I'm doing this. That fuel pump is still going too. Let me see what happened. Nope. I know this car's flooded now. It's gotta be. It's gotta have a code, man, because nope. Alright, well, not everything goes planned. So I'm pretty sure it was a combination of other things that has also occurred, but now we know. Let me get this module taken out and we'll inspect the harness and go from there. Just for shits and giggles. If you're curious to see if the damn thing will start up because I did all that, we're gonna find out, because I haven't tried to do anything yet. Let's see if it starts up. Wait, start it up. The module is supposed to have some paste on there, but I know when he said he bought one, he bought this like several years ago from Rock Auto off of, well, bought it off of Rock Auto, and these were AC Delco products. Well, it's funny because this is AC Delco. It's a Standard Motor product company unless Standard Motor products make AC Delco products. So allegedly we got our authentic AC Delco module. So let's take a look at that. This is AC Delco. It's from O'Reilly's, unless this is a knockoff. But this doesn't have a Standard Motor product name on there. And O'Reilly still Standard Motor products. So this is the new one. This is the old one. And it's a Standard Motor product, because O'Reilly sell it, man, it's got to be high quality. Let me see if we can see that real good. Standard Motor product, Inc. This doesn't even have a name on it. It's so authentic, so genuine. It doesn't even have a name on it though. That's the crazy thing. Nothing that displays it that says it's a AC Delco. I'm overlooking something. Well, either way, here's the accessories it came with. I'm gonna put those in there, assuming that I don't drop one. These grommets right here help with water from getting inside of there, inside of the connector, and distorting things. So just like when you wash your engine, you want to wash it, they say wash your engine when it's hot, because at least I guess it gives it an opportunity to evaporate the water that could potentially get in there, or just avoid electrical components to begin with. But just as we saw, I mean, that test light that I use, it works very well for bias voltage, but that can be enough to alter signals, because to persuade it, just like we did, even though it's nothing significant that's going to blow a circuit. So I get that in there, push down. I'm gonna look inside the other one there and see if it had the insulation, because I don't remember ever seeing any. I missed one. There we go. That's another one. All the pins are okay, so I think we'll be fine. Let's look inside the other one and see if there's any insulation. Yep, it is right in there. But it's a standard product. I mean, standard products work better than AC Delco stuff. Trust me, I know. I mean, I shop at O'Reilly. I spend a lot of money there annually. I don't know if you heard the sarcasm. You don't have to do that. I did say we were going to check the connector, the wiring harness, that is. So now, I didn't know any other manufacturer to have to put a dielectric grease under the bottom at the base where it connects to the bracket, but I just know dielectric grease or some pipe of paste need to be on here. So that's where I'm going to put it. Well, I'll tell you what, let's go ahead and inspect this first. So these are our grounds, the black and whites. And, this is the majority of things that I move right here anyway. So if anything got grounded, it would be allegedly around this area here. So I just slightly move the wires around. I'm not going to break my neck checking further up. And truth be told, I mean, everything looks fine, and I was hoping, if anything had happened, the wires would probably be frayed and burnt up. I know somebody's gonna talk about my job here. It's not a big deal. I ain't gotta worry about anything happening. I know I'll be fine. I'm not going to put any dielectric grease inside of here, simply because I know it can distort the connections. I'm going to also inspect these pins in here because GM can have issues with the pins. Take a better look. These have like some spring tension on them. They kind of face like this. So when you slide the pin in there, it keeps pressure on it, pushing up on the pin here. So if you see them collapse, then you want to address that. But this doesn't reflect the kind of problem that we had because we had an interpretation issue. So we had to internalize grounding. I didn't go off and tell you what I used to pull this off. It was a 5.5 and a 7 millimeter. Put these back. That was a 7 millimeter. I'm gonna put this back here. Get my new coils. These also came with some rubber inserts, but we're not going to use those because we already have some. Usually I mess up the timing with these when I put these back in there, but if I don't, then all right for me. Normally I'll screw something up. Let's see if it starts up, or if I screw up the timing or not. We already got the values of when we hooked up everything. I'm gonna make sure I got everything hooked up appropriately as last time, so there's no confusion. We're gonna check the inputs and outputs again and see if there's any difference. 'Cause before we had 6 volts on the input, which I doubt would change, but who knows. And then on the output we had 5 volts. Let's just see if those are all the same. Modules installed, and already we see a difference. And I do have the notes here from what we looked at before, and unless you didn't register yourself. So channel A is normal. However, channel B is of 1 point. I was about it was like 1.1 volt difference. So channel B was at 6 volts, but we're going to find out if that goes back up to 6 volts once we get it started. Channel B is the crank position sensor to ICM. Now, what this means, if the voltage was higher, it could be a fault with the module supplying voltage to the crank sensor being improper. So that could have been a sign that there's something wrong with the voltage going to the crank sensor, which could have indicated that there's a potential problem with the module inside because it can't regulate 5 volts. This system obviously operates off of a 5 volt reference, and we should have seen a 5 volt square wave because that's what's going to the computer. So the input to the crank position sensor could have been overvalued, but the output from the module to the PCM was able to be regulated and reduced to 5 volts. Could be. So that's something that we could call into question there. So let's start it up. We know it starts up. We know we got timing right. So let's look at the square wave and see if there's anything different, or if what I'm thinking was correct in the values needing to be 5 volts. So let's see what happens. Yeah, I still got it sitting up here. I should have put it somewhere else. So the values did go back down. Seem like they're more closely matched than what they were before. Go to 10 milliseconds. And the average voltage, the maximum voltage can change depending on the scale. So just to be mindful of that, put it on 2 seconds and see if there's any difference. Yeah, so just to be mindful, but I'm just looking at what we had before. So on 22, oh, just 200. 20. So on a 20 millivolt scale, it's still around 5 volts. If I go to 10, I said 10 millivolts, 10 millisecond scale, it's still around 5.4, 5.5. But like I said, there's something to potentially call into question, but that is like a notable difference. If I were to shut it down, it'll likely be around 5 volts versus 6 volts where it was before. So. Oh shoot, I don't want to do that. Let's go to, I have a habit of pushing certain buttons. So there's the 6 volts you just saw it up there, the maximum. And again, it's max, so it was better than the average that we had got before. So I wonder if I can change. All right, so we got shut the car down, key on, engine off, obviously. And the voltage is around 5 volts. It's not 6 what it was before, so I'm not sure if that made a significant difference or not. But I mean, this is a new parts, the AC Delco from what it said, and from the box said that the brand isn't stamped on the product like Standard Motor Company was. So, I had a few things answered, had a few things that kind of got thrown under the bus. But you know, the car's not broken, so it's gonna be hard to fix something that ain't broke, especially when, you know, I don't have the complete knowledge to be able to narrow down electrical circuits. I'm not a pro at this by any means. We obviously seen some changes with the old part versus the new part with the oscilloscope and the values. We looked at the coils and the base of the module. We looked at the connector. We inspected the wiring harness where I was moving around before, you know, there was nothing crazy. We even looked at the values, did a wiggle test on oscilloscope on the appropriate trigger, the 18X, assuming that was given the improper values. I mean, and based on the context clues, I mean, this is the only thing I can come up with, but we know that it needs a drop-off signal to determine it was running. We was able to emulate that. Unfortunately, I didn't get a check engine light, but I'm pretty sure based on what was going on, depending on if I was able to hook up on the 18X crank sensor during the issue, we would have got some different things. So unless it was like completely broke, I mean, this would have been totally different. And I guess I can't be disappointed at the way things turned out, simply because, you know, we got the car running, we know what area we were supposed to be in, and I still am a firm believer in the context clues that led up to the vehicle thinking it was operating when it wasn't. Unless we, you know, if otherwise we wouldn't have got those components operating uncommanded. So. But if it comes back, I'll definitely update. I'll try to keep as much information as I can on this vehicle if it does come back for the same problem. But I will say this: if you ever get a flooded engine, you know, if you think that if it's locked up, just make sure that this engine, if you have 3800 and it's around the same year, just make sure the vehicle didn't go through the same situation and hydro lock, essentially like lock up. Pull the plugs out, see if it's flooded, see if it's if you have fuel in the cylinders, you know, just check all that and take the plugs out, spin the motor over, and make sure it's not gas or coolant, because these intake gaskets can blow, making you think it's the head gasket. So this case, it can flood the cylinders also, depending on how many times you try to start it up. You know, yesterday when I was trying to start it, I intentionally pulled the fuel pump fuse to see if it was sparking and trying to start up, because it was flooded, because it sounded like the cylinders were washed, which they were, because we had the injectors pulsing when they weren't commanded to, when they weren't supposed to, because the engine wasn't supposed to be running, but the injectors were. So if you know anything, just let me know. But I think I went as far as I could go, as far as my knowledge capabilities will allow me. But if anything happened, I'll definitely update the comment section, just like I did yesterday, as far as what I'm currently doing today. And if we hopefully I have more than enough information for somebody to be able to look at PID-wise, and they can go through some process of elimination and contrast based on their situation. But if anything happens, man, hit that link, subscribe to the channel, stay informed, have that reassurance of my work. So I'll try to keep you in a loop, man. But other than that, see you next one.